Good evening. Today we are going to solve the problems which are from exercise 1. So we have these three problems which we have to solve in assignment number 1. So we will start one by one. So this question was asked in IES examination, and we have to find out value of A, which is overhang, such a way that we are going to get maximum bending moment to be minimum. And then we have drawn this as per given in the problem, that is beam L. So we have total beam L carries a load W per unit length, so W kilonewton per meter on its whole span. It has one simple support at its left end, and other end is at a distance of A from the other end. Means from other end at a distance A, we have another simple support. Find the value of A. We have to find A such that the maximum bending moment for the beam is as small as possible, and we will get this maximum bending moment as small as possible if we have hogging bending moment equal to sagging bending moment. So now first we will find a reaction. We will take moment about B0. So we have RA into L minus A. Now we are going to get this distance will be L minus A. So RA into L minus A minus W into L minus A into L minus A upon 2. So we have considered, we are taking moment about B. So first we have considered this portion only, which is L minus A. And therefore we are going to get this as L minus A into L minus A by 2. So we have this one minus, because bending moment due to this reaction we have clockwise, due to this we are going to get bending moment anti-clockwise, and due to this actually we are going to get it as clockwise again. So this should be plus wa into a by 2. So from this we are going to get this value, that is equal to, so you can see this. Now we have w into L minus a upon 2 we have taken on this side, and that is minus. So this actually will go on right side, so this term becomes plus and this term becomes minus. So we can see this L common we have, that is W into W upon 2. So we have this portion and this we will have taken common, and this L minus A we are going to be on denominator side, on right hand side, and then in bracket we will have L minus A whole square and minus A square, and from this we will get RA. Then we will simplify it, so we are going to solve this. So we will get this as L square minus 2LA plus A square, and therefore again minus A square. So this A square gets cancelled. We have L square minus 2LA. We have again taken L common from both, and therefore we will get L minus 2A inside. So we are with this W into L minus 2A upon 2 into L minus A. Then we will have maximum bending moment, which will be at center of this L minus A, and then bending moment will be at center, which we will have L minus A by 2. So L minus A by 2. And therefore we will take moment about this, and we will equate moment at B, which is sagging bending moment, and we have hogging bending moment at center of this. So we have RA into L minus A upon 2 minus W into L minus A by 2 into L minus A by 4, because it will act at center of this, and therefore we will get this distance as L minus A upon 4. And then we have equal to WA square by 2, because we have bending moment on this side, we have W into A by 2, and then we have WA square by 2. And then we will have value of RA WL in bracket L minus 2A upon 2 into L minus A. So we have substituted this value of RA then into L minus A by 2 minus, so this part as it is, which is equal to WA square by 2. Now we will again simplify this part, and we will get it as, now you can see we have W in all, so we have cancels W from all, so all three terms we have cancelled it, and then we will get it as L into L minus 2a. We have cancelled out this LL from this, and then we have cancelled 2 from all, so we have 2 gets cancelled from all. So we have L into L minus 2a upon 2, that will be in first term. In second term we have L minus a whole square upon 4, and that is equal to a square. And then we will simplify this, so we will have LCM 4, and that will go on this side, so becomes 4a square, and then we have to multiply this by 2. So if we will multiply all terms by 4, then you can get it very easily. So we have these two twos are, and then we will multiply 2L into L, 2L square minus 2L into A, 2A, so minus 4AL. Then we will have this square. So we will solve this square, this 4 gets cancelled. So minus L square, then minus minus plus 2LA and minus, so this will be plus minus minus a square equal to 4a square. And then we have simplified this. So we are going to get L square minus 2al minus 5a square equal to 0. And then we will solve this. A equal to minus b plus minus root of b square minus 4ac upon 2a. So here we have minus b plus minus root of b square minus 4ac upon 2a. Now a we have 5, then b we have 2a, and then C we have minus L square. So we have minus B, so minus 2L we are going to find out value of A, so we have this will be 2L. So minus 2L plus minus B square, so 4L square, minus minus plus 4, A is 5 and C is L square upon 2 into 5. And if you solve this, you will get A equal to 0.29L. And then we have to find maximum bending moment. Again, we have WA square by 2. That both are same. So we will substitute in this value of A as 0.29L. And from this, we will get value of maximum hugging moment 0.042 WL square. So we have actually WA square by 2, and value of A we have 0.29L. Then second problem, actually we have this as third, 6 kilonewton, 2 kilonewton per meter, and we have to draw SFD and BMD. So first we will draw FBD, and we will find reaction. So moment about A 0, 6 into 1 plus 2 into 2 into 3 minus RB into 4, we will get RB 4.5 kilonewton. FY 0, we will get RA plus RB, and that we will get RA equal to 5.5 kilonewton. So now knowing this value, we will go with SFD shear force calculation, left of A 0. So we have this as A, we have this as B. Then left of A 0, then we have right of A 5.5, left of D we have same value, right of D we have 5.5 minus 6 minus 0.5 kilonewton. Then at C we will have same value minus 0.5. Left of B we have minus 4.5, sorry, left of B we have minus 4.5 kilonewton minus 4 point sorry, we have that is right at C we have minus zero point 0.5. Left of B we have actually, if we will solve this, then we have minus zero point 0.5 minus 4, and then we will get it as minus 4.5 kilonewton, and right of B 0. Bending moment at A 0, bending moment at D 5.5 into 1, 5.5 kilonewton meter. At C 5.5 into 2 minus 6 into 1, 5 kilonewton per meter. If we will calculate from right side also, then from right side we have anti-clockwise plus, so 4.5 into 2 minus 2 into 2 into 1, and that also comes 5 kilonewton meter. And then at B we have 0. So we will plot it. At A we have 0 and 5.5, same value we have left of B. The D, right of D we have minus 0.5. Then at C we have zero point 0.5. Then at B we have minus 4.5, and at B we have 0. So this we have SFD in kilonewton. So we have this as SFD in kilonewton, and then we will plot BMD. So we have BMD 0 at A, At D we have find 5.5 kilonewton meter, at C we have 5 kilonewton meter, and at B 0. Now you can have this will be x to the power 0, so this becomes x to the power 1. So we have x to the power 0, x to the power 1, and then x to the power 1 we will get it as x to the power 2. Then we have actually this will be problem number 3. Last one is problem number 2, and then we have FBD moment about A0 minus PB. So we are taking moment about A0. So due to this minus PB, then due to this P we have minus PB because again anti-clockwise B plus L, and then due to RB again minus RB into L equal to 0. We will get RB which will be minus 2PB upon L minus P. Then we have Fy0 Ra plus Rb, and that is equal to 0 because if we will write this, so we have minus P and plus P, so that becomes 0 again. And Ra we will get 2PB upon L plus P. And then we will go for calculations, here calculations, left of C 0, right of C minus P, left of A minus P, right of A minus P plus 2PB by L, plus P is 2PB by L, left of B same value, right of B we have 2PB by L minus 2PB by L, and we will get this value that is equal to minus 2PB by L. So this we will get it as minus 2PB by L. Then we have left of B minus P, and right of D we have 0. And bending moment calculation, at C we have 0, at A we have minus PB, at B we have plus PB, and at D we have 0. So we will plot it P, then we have P here, then 2PB by L, 2PB by L, 2P, then P, and then 0. And then we have here that PB and minus PB and plus PB. Now again here you can see this is SFD we have in kilonewton. This is BMD in kilonewton per meter. So here we have x to the power 0. Here everywhere in shear force we have x to the power 0. So in bending moment you are going to get everywhere that is x to the power 1. So these are the problems which are in exercise 1. So thank you. Today we will stop here only. So